Ready to have your brain rewired? Today we're counting down 9 discoveries that broke science in the most delightful way. Let's start with something squishier than a dinosaur bone should ever be. Number 9, dinosaur goo that shouldn't exist. Imagine cracking open a 68-million-year-old T-Rex leg and finding something that bends. That's what paleontologist Mary Schweitzer stumbled on: stretchy tubes that looked like blood vessels flexing like tiny rubber bands inside fossilized bone. Here's the twist. Soft tissue isn't supposed to last normally. It vanishes faster than your New Year's gym routine. But this bone had a built-in preservative. Iron from the animal's blood likely acted like nature's embalming fluid, cross-linking the molecules the way museum curators save artifacts, except the T-Rex accidentally mummified itself from the inside out. At first, lots of scientists said no way. Fossils are supposed to be rock, not gummy candy. But under the microscope came more surprises: vessel-like structures and even cell-shaped blobs where red blood cells should be. The chemistry hinted at ancient proteins hanging on for dear life. So yes, the skeleton in your museum looks dry and stoic, but inside those stone-hard bones, there might be a prehistoric echo of the animal's biology. Microscopic tubes that bend, not break. Next time you meet a T-Rex skull, remember somewhere in that rock, the past is a little more squishy than we thought. Number 8. The 95% we can't see. Look up at the night sky. Every star, planet, and glowing galaxy you can spot is just the tip of the iceberg. In fact, it's only about 5% of the universe. The other 95%, completely invisible. Scientists gave these ghosts names: dark matter and dark energy. Dark matter is like the hidden scaffolding of the cosmos. Galaxies spin so fast they should fling themselves apart like clothes in a washing machine on max cycle. But they don't. Something unseen is holding them together: dark matter acting like an invisible glue. And then there's dark energy. This is even stranger. It doesn't pull things in. It pushes space itself outward. Imagine plastering galaxy stickers on a balloon and then finding the balloon inflating on its own. No hand, no breath, just expansion. That's dark energy, and it's thought to make up nearly 70% of the universe. The weirdest part: we have no clue what it actually is. It's like discovering your phone battery keeps charging while unplugged. Astronomers stumbled on this almost by accident, and many still wish they hadn't, because it means everything we see, touch, or measure is only a cosmic rounding error. The universe we know is just a slice, and the rest is a riddle made of darkness. Number 7. The planet that wasn't there. Back in the 1800s, Mercury was misbehaving. Its orbit didn't match Newton's equations. It wobbled just a little too much. Instead of questioning, the math astronomers invented a new culprit: an unseen planet tugging on Mercury. They even gave it a dramatic name: Vulcan. For decades, the hunt was on. Some swore they saw Vulcan crossing the sun. One French astronomer even got a medal for spotting it, though what he probably saw was nothing more than a sunspot. Reports kept piling up, and Vulcan became the most famous planet that never existed. It was like a never-ending game of hide-and-seek, with an imaginary friend. Then along came Einstein. With general relativity, he showed that Mercury wasn't being yanked by some hidden world at all. The orbit's odd tilt came from something far stranger: space itself is curved. Gravity wasn't a force tugging in straight lines, it was geometry, bending around the sun like a giant cosmic trampoline. Suddenly, Vulcan vanished, not from the sky but from textbooks. Astronomers had spent half a century searching for a ghost. It's the cosmic equivalent of frantically looking for your phone while you're already holding it in your hand. Number 6. The end of order. Picture 2 planets orbiting each other. They move so smoothly, it's like a cosmic waltz: every step predictable, every beat on time. Astronomers loved this. It meant they could calculate exactly where the planets would be centuries into the future. Then someone asked, what happens if we add just one more planet? Answer: all hell breaks loose. With 3 celestial bodies tugging on each other, the dance turns into a cosmic bar fight. One pulls this way, the other jerks that way, and soon the whole thing looks less like ballet and more like drunk teenagers bumping into furniture. This is the infamous 3-body problem. Even the best supercomputers can't solve it with perfect accuracy. The system is so sensitive that a tiny difference in starting conditions spirals into total unpredictability. One misplaced decimal and your planet ends up flung into deep space. And here's the kicker: this isn't just abstract math. The same chaotic principles ripple through weather systems, financial markets, and yes, even why your earbuds always tie themselves into knots in your pocket. The universe isn't a Swiss watch ticking with perfect order. It's more like a mosh pit where everything collides, rebounds, and surprises you all over again. Number 5. The universe's worst prediction. Science is supposed to be precise, but once in a while it faceplants so hard it's almost comical. Case in point, when physicists tried to calculate how much energy empty space should have, they missed the target by 120 zeros. Let me put that in perspective. That's like guessing your friend weighs as much as 1,000,000,000,000,000 galaxies when in reality they weigh as much as a hamster. Not just wrong, embarrassingly wrong. Here's why it happened. Quantum mechanics says empty space isn't empty at all. It's buzzing with particles popping in and out of existence like an eternal microscopic rave. Meanwhile, Einstein's relativity says that all that jittering energy should bend space itself. Put the two together, and the math screams, there should be so much energy the universe would have blown itself to bits instantly. Except when scientists actually measured it, the energy of empty space was basically a yawn, closer to a sleepy sloth than a cosmic rave. This mismatch has a name: the vacuum catastrophe, the single largest error in the history of science. It's the universe's way of reminding us even our sharpest theories can look like broken calculators when combined. Number 4. The Pluto problem. For decades, Pluto enjoyed life as the scrappy ninth planet. Posters, textbooks, and classroom mobiles all gave it a proud spot at the edge of the solar system. Then came 2008. Astronomers found Eris, a lump of icy rock even bigger than Pluto, just hanging out in the Kuiper belt. Suddenly, Pluto looked like the kid who barely makes the basketball team and then gets benched when someone taller shows up. Faced with the prospect of adding dozens, maybe hundreds of new planets, astronomers decided to draw new rules. Rule 1, you must be around. Pluto passed. Rule 2, you must orbit the Sun. Pluto passed again. Rule 3, you must clear your neighborhood of other space junk. And that's where Pluto failed miserably. So in 2006, Pluto was officially demoted to dwarf planet. Teachers sighed, students groaned, and janitors had to scrape Pluto stickers off 1,000,000 classroom walls. But here's the funny part: Pluto itself doesn't care. It still orbits, still spins, still wears its icy heart-shaped crater like a badge of pride. If anything, it's smirking at us from afar, watching humans argue over labels while it keeps doing its thing. Pluto may be small, but it's got the biggest attitude in the solar system. Number 3. The leaky black hole. For years, black holes were the ultimate cosmic prisons, places so powerful that even light couldn't escape. Once you crossed the edge, that was it, game over. Then along came Stephen Hawking, who broke everyone's brains by saying, actually, black holes leak. Here's how. At the rim of a black hole, space is bubbling with pairs of tiny particles popping into existence. Usually they annihilate each other instantly, but near a black hole, one particle falls in while the other escapes. To the outside world, it looks like the black hole is slowly evaporating. And that creates a huge headache. Because if black holes can vanish, what happens to all the information about the star's gas and unlucky astronauts they swallowed? According to quantum mechanics, information can't just disappear. It's like burning a book. The pages turn to ash, smoke, and heat. But technically, the information is still there. With black holes, it looks like the book and the story just vanishes forever. This is the infamous information paradox. And it's so puzzling that physicists joke it's the cosmic version of dividing by zero. So now, either our understanding of gravity is broken, or quantum mechanics is broken, or most terrifying of all, both are. Number 2. The cosmic speed limit. Every highway has a speed limit. The universe does too: 186,282 miles per second. And this one isn't enforced by cops. It's enforced by physics itself. Before Einstein, scientists assumed you could just keep hitting the cosmic gas pedal forever. But Einstein showed that as you approach light speed, weird things happen. Your mass doesn't stay the same at balloons. It's like pushing a shopping cart that mysteriously fills with bricks the faster you shove it. Near light speed, that cart would weigh more than the entire Earth. Try to actually hit light speed and the math says you'd need infinite energy. Basically, the universe would laugh and say, nice try. Light itself gets a free pass because it has no mass. It's like the one traveler who sails through airport security without luggage while everyone else is stuck juggling suitcases. And the dream of zipping across galaxies in minutes. Sorry. Even at top speed, crossing just our Milky Way would take you 100,000 years. Science fiction turned into a cosmic reality check. So if aliens are out there, they're probably not avoiding us. They're just stuck in traffic that spans entire galaxies. Number 1. The water that wasn't. Back in the 1960s, Soviet scientists thought they had stumbled onto something world-changing, a brand new form of water. They called it Polywater, and it was thicker, denser, and just plain weird. Supposedly, it refused to freeze, refused to boil, and had the consistency of syrup. The hype spread fast. Researchers warned it could be contagious. Ordinary water might catch Polywater's properties, turning the oceans into sludge. Journalists whispered about the end of civilization brought on by evil H2O. It was basically a zombie apocalypse, but with tap water. The supposed boiling point. Around 400 degrees enough to cook your ramen in 2 seconds flat. The possibilities were terrifying and exciting all at once. But then came the reality check. After careful investigation, scientists discovered the truth: polywater wasn't exotic at all. It was just plain water contaminated with sweat dust and soap residue from dirty lab glassware. In other words, the new state of matter was lab funk. So next time you feel embarrassed about messing up at work, remember this. At least you didn't convince the entire scientific community that you'd discovered magic water only to realize you'd bottled dirty dishwater. Outro rewritten, and that's the countdown: 9 scientific stories that prove the universe is way stranger and sometimes funnier than we give it credit for. From squishy dinosaur tissue to vanishing planets, from cosmic speed limits to magic water that turned out to be dirty glassware. The lesson is simple. Science isn't just about answers, it's about surprises. Which of these blew your mind the most? Drop your pick in the comments, I'd love to know. And don't forget to hit subscribe for more journeys into the bizarre side of reality. The next mystery might just be weirder than all of these combined.